So what is chi-square test? Chi-square test is also called as test of independence. Test of independence, chi-square test. So we use the notation something like that. This is called chi-square test of independence. So what does this chi-square test is all about? It's also a statistical test, right? So using the chi-square test, we can assess the goodness of it between a set of observed value and those expected theoretically. Okay, and see, we are trying to find out assess the goodness of it between observed and the expected value. Observed is your actual value, actual value and the expected value. So what do you mean by actual value and the expected value in general here? What is the actual value and expected value in general? Let's say you want to start, you want to paint your flat apartment, okay, and right. So so what you do is right. Yeah, what we do is actual and observed. Okay, it is slightly different. I need to use different example here. Okay, you just think at this moment, right? The actual, observed and observed is nothing but actual minus expected. It's something like actual is it's something like observed. Actually, something like let's say a baby born on um, uh, let's say a baby born on 5th January. Okay, minus the expected. But we were expecting that the baby was about to born on 10th, right? The actual date when the baby born 5th, but the baby was initially we expected that the lady would give birth to baby on 10th January. So 5th minus 10, 5 minus 10 whole square divided by the 10. That is what your chi-square. Observed minus expected divided by expected. This is a very simple one, but remember this, okay? What is the property? It is based on frequencies, not on the mean and standard deviation. So far, we discussed so many tests, right? Hypothesis test and ANOVA test and all. All these tests were related to what? Mean, right? Mean. But when it comes to chi-square test, so not all the time right, so you get mean and standard deviation, right? Sometimes you may get the values in terms of frequencies, not on the parameters. Okay. So right, that is what in that kind of situation we use chi-square test. Okay. See, for example, mm, let's say your relative is undergoing a surgery. Okay, some surgery. So you want to compare various hospitals, the success rate. Okay, how many patients they survive? How many number of patients survive? Let's say you are taking the last 6 months of data. And in Chennai, we have Apollo Hospital and SRM Hospital, Mayat Hospital, Triple M Hospital. Each hospital for the same treatment. Okay. Let's hair transplant, right? Complete recovery in the sense, right? Complete full hair. How many number of patients? They have the after the treatment surgery. They have a dense hair. Okay, and partial hair only is there. Okay, not full hair. They developed it, and completely it remains bald only. No matter what they did, still it remains. So I don't want to use some negative thing like kidney transplant, other thing. Okay, let's use some hair transplant, something like that. Okay, so here basically the chi-square test helps us to find out the association between two attributes. Okay, two attributes, right? Not, uh, or we can say the two categorical variable, right? So you want to find out the relationship between or association between two categorical variable. Okay, for this, we will look at an example. Don't worry. Before that, let's understanding the distribution pattern. The chi-square test, and even if you do the googling, right? So chi-square test for association, the chi-square distribution. It will be something. Usually, it will be like this. Okay, the chi-square distribution will be something like this. So this is a family of distribution called chi-square. So chi-square, we pronounce it as chi-square. It is written as something like this. As is the case with t, the determining parameter of chi-square is the degrees of freedom. Like in the case of t-test, we find out the degrees of freedom, right? Something like this here also. Okay, how do I formulate the null and alternative hypothesis in the case of chi-square test? In the case of chi-square test, how do I formulate the null and alternative hypothesis? Null hypothesis, we always start with a no, okay? State that no association exists between two categorical variable. Or is it? Yeah, there is a relationship with the two categorical variable, okay? But the theoretical way of writing this, an outcome is independent of factor x. No association between outcome and hospital. Outcome y is not independent. So outcome is independent. Outcome is not independent. That's what order. But I don't want to discuss this now. We'll start with the example so that you'll be able to understand the previous step. Sometimes, right, we have to take a bottom-up approach. Not all the time top-down approach will work. We'll take this example so that you'll be able to understand. So I have two categorical variable, okay? Name of hospitals and other categorical column is outcomes. Name of hospitals, I can say no triple M hospital, Mayot hospital. That column contains these four values. Name of hospitals column is a categorical variable that contains triple M hospital, Mayot hospital, Apollo hospital, SRM hospital. And I have another categorical variable called outcomes. Outcome columns contains these three categories. Okay. This column contains these three categories and the name of hospital contains four categories. Okay, and this table shows that the number of transplantation surgeries performed at each hospital and their outcomes for the last 12 months. For example, let's say, okay, take kidney transplantation or heart transplantation, right? After doing the heart transplantation, so there could be various possibilities, right? Some person may die. Maybe the surgery, sorry, the transplantation may not be successful. Death. There are some cases of partial recovery. It's not fully they recovered and complete recovery. Complete recovery, yeah, after transplantation, in 6 month time, or in 1 month time, they recovered completely, or 15 days they recovered completely. Partial recovery in 15 days, right? They recovered, but not fully. Still, they have some breathing troubles, all the things. Okay. Okay. So there are two categories. If you want to find out the relationship between outcome, the column outcome, and the name of the hospital. Obviously, right? The outcome also depends on the hospital, right? Outcome varies between the one hospital, other hospital, the outcome varies. So here you noted down all the values based on the survey which you or the data that you collected. So in Triple M hospital, those people underwent heart surgery. 18 people they recovered it completely. But in the Mayot hospital, 50 people there, and Apollo 76 people there completely recovered. In SRM hospital, 32 people recovered. And if you see a partial recovery, 9 people partial recovery, 28 people partial recovery, these are the values. Here the number of occurrence of values, right? So you cannot take average and all here, right? It's how many number of people they completely recovered in each hospital. That's what we can see it here. Okay, how many number of people partially recovered? How many number of people died? The number of occurrences we note down, right? So basically we want to find out, are there any association exists between the outcome and hospital. Here we assume that no association between outcome and hospital. The alternative, yes, there is an association between outcome and hospital. Obviously, the quality of the hospital also matters, right? So that is the one we need to conduct the test. So we conduct the test, the same value I just wrote it down here, right? And then I did it, and then this is where observed value, actual values. What is the expected value? How do you derive the expected values? So you need to use some formula here, okay? Expected value is equal to column total. So you need to find out the column total and then row total. Add all the values, that's the row total. Add all these values to column total. Again, you add this column, this is your column total, this is your column total, this is your column total. Okay, this column total into your row total divided by grand. So if you add all the values, you'll get some grand total, right? So that's what you can see. This is your grand total. Okay. And here, this, if you add all the values, your column total into this row total, and divided by 270, you will get this value. And again, this column total into row total divided by 270, you'll get this one. So they expect this. See, you have actual values. You need to derive the expected values. How do you derive the expected values? You need to take the column total and then row total. For each column, you take the column total and then the row total, the corresponding row total. Okay. Column and row total divided by grand total. Okay. And once you compute this, you will get these values. Okay. And then this is your column total, right? Look here, this is your column total, column total, column total. This is your row total. So 38 into 176 or something divided by 278. And you will get this one. And 90 is your column total and row total divided by grand total, you'll get this one. Something like this, you'll get. And then partial recovery also do find out the same thing, okay? So here degrees of freedom is column minus 1 divided by rows minus 1. How many columns? Four columns. Minus 1 is 3. And rows, 1, 2, 3 rows. 3 minus 1 is 2. That's our degrees of freedom. Okay. So in Excel, we have some CHA test. There is a function called CHA test. So what you need to do is you need to select all the values. Pretty simple there in Excel, right? Comma, all the actual values. So C3 colon FI is this one. All the values are your actual values or observed values, comma, you need to, select all the expected values. It will give you p-value, 0.00064. Again, the same rule. If the p-value is less than alpha, reject the null hypothesis. What is alpha? Alpha equal to 0.05. That's why I told, right? That's what I told you. Since the p-value is less than alpha, we reject the null hypothesis. We are going to conclude that there is an association between outcome and hospital. Outcome is dependent on the hospital, but we assumed that the null outcome is independent of the hospital. Okay, outcome and hospital is nowhere related. That is the null hypothesis. We rejected it, and then we concluded the outcome and hospital as an association. இந்த ஹாஸ்பிட்டலுக்கு போனால் இவன் படிச்சுக்குவான், இந்த ஹாஸ்பிட்டலுக்கு போனால் அவ்வளோதான், கவர்மெண்ட் ஹாஸ்பிட்டல் போனால் டவுட்டு தான் இல்லையா? பேஷண்ட் நல்லாவே போவான், அவன் வந்து பார்த்தீங்கன்னா ஏதோ வயிற்று வலிக்கு போயிருப்பான், அவன் பார்த்தா அவங்க அனஸ்தீசியா கொடுத்து என்ன பண்ணுவோம், ஒரு கையை எடுத்துருவோம், ரைட்? நான் போனது வயிற்று வலிக்கு, என் கையை ஏன்டா கட் பண்ண, முழிச்சு பார்க்கும்போது கை இல்லையடா. That's what happened in Chennai one hospital, right? Again, I don't tell anything. So with chi-square test, we can find out the association between two categorical variables. Here, there is no mean comes into picture. We are not taking now because here we have collected the number of occurrences of each thing, right? In a triple M hospital, how many number of patients completely recovered after they underwent the transplantation? Each hospital is noted out, and then we computed the expected value. How did we computed the expected value? So expected value, how did we compute that? So column total into this specific row total divided by grand total, that value get it. Column total into this row total divided by grand, you get this one. Column total and then this one, you get this one, and this one the same thing. This column total into row total, you'll get this one. Okay, that's how we got this one, right? Yeah. Similarly here, yes, the question is, yeah, Varun asked this question. How about 8.74? How about the second row? Yeah, in the second row, this is the row total, right? This column total into this row total divided by grand total. This column total into this row total divided by this one. This one divided by this one into this one, this one into this one divided by this one. When it comes to this one, this column total into row total, and then this column total row total divided by this one, right? That's how we got the expected value. Okay, this is, see, 3890, this is your column total. If you add all the thing, how much you get? 18 plus, sorry, 11 plus 9 is 20. 20 plus 18 is 38, right? Yes. So 78 plus 12, 80, 90. The column total and grand total also I put it here. Row total also I put it here. So column total into row total divided by this one. Yes. So you already computed, right? Yes. That's how you get it. So once you derive the expected values, you need to select all the observed values, and then you need to select all the expected values in your chi-test. And then if you use an Excel sheet chi-test, right? If you select these cells and these cells in the second argument, you get p-value. P-value is this one. P-value is less than alpha. We reject null hypothesis. Obviously, 0.00064 is somewhat closer to zero, right? So it is obviously less than 0.05. Hence, we reject the null hypothesis. P is less than alpha, reject the null hypothesis. Don't ever forget it. So we are going to conclude we are going to the outcome and hospital as an association. There is a relationship exists between these two categorical columns. This is one of the examples, okay? And yeah, the table, okay, you can manually how you can find out. So same thing, okay, chi-square equal 23.64. Your chi-square value is 23. Sum of all the values from the above table. All the values from the above table, you will get some value, chi-square value. And here degrees of freedom, okay, 7 and 0.005, right? Yeah, you'll get 20.28. That is what your cutoff value, the critical value. Since your chi-square value is 23.64, which is greater than this one, it's falling in the rejection region area, we are going to reject the label. This is a manual way of doing it. No, man, I just want to chi-square test, right? Or the Python also has some chi-test and all is there. We will see how to do the test in Python later, okay? So now we are going to now answer. Now we got an answer, right? Does the choice of hospital affect surgical outcome? Yes. That's what we are going to conclude. So the surgical outcome is independent of hospital. Outcome is dependent on hospital. We are going to reject this one. Yes, outcome is dependent on the type of the hospital, obviously. Okay. So another example, to devise an appropriate marketing strategy, they have sampled 50 respondents to ascertain if there is any association between age and the choice of mobile phone brand. Okay, age and the choice of mobile phone brand. Here, two categorical. One is the brand, and the other one is age bucket, something like that. So here, male. Let's say in this case they've taken male. Okay, 20 to 30 years. This many number of iPhones they bought it. 31 to 44, 50. So again, middle-aged people they buy more because their income is more, and as they grow old, their income is less. The chance of buying is less, right? The young age, right? Obviously, they are also likely to buy more. Okay, but we based on the survey we ran it, we got this information. Okay, and Samsung how many they purchased it, and Moto G how much they purchased it. Okay, fine. So these are your actual values. The blue colored one is your column totals, and this is your grand total. This is your row total. You add all the value row total. If you add all the column total, if you add all these values, right, the three rows, we'll get a grand total. Now we have the column total, row total, grand total. Computing the expected value is pretty simple. So your row total, sorry, column 173 into row total divided by this one is your 52 point. So when it comes to this column, you take this column total, this row total divided by this one, you'll get this value. Similarly, you need to take this column total and then this row total divided by this one, you will get this value. And then, right, so that's all. Okay, I'm going to leave here we left the row total as it is, column total as it is. So we got the observed values. So these are actual values, these are observed values. In your Excel sheet, right, if you put a table something like this, two tables, and then if you select all these these three columns, right, and these three columns as your observed values in your chi-test function. You'll get the p-value. If the p-value is less than alpha, you're going to reject the null hypothesis. Otherwise, you're going to accept the null hypothesis. There is no association between age and buying the mobile phone. If you reject it, yes, there is an association between age group and the brand also. Another example is you can work on this thing. Okay, I thought you guys, I shared the link to you all. The assignment one, assignment two. Assignment two, you can go and make an attempt. At least tomorrow daytime or so. You practice it. Okay. So okay, we are done. Pretty fast. Okay. Um, So we are going to wrap up. See, this is the one. With this, I'm going to wrap up the session. Meanwhile, you complete all the hypothesis testing later assignments and other assignments. For that, which I shared the link to you, right? You can make an attempt and then you can come back with your solution. And probably you can share that in the word PDF file. Okay, we'll take a look at it. Right? Fine. Yeah, conducting the test in Python, right? We will show you later because I kept the script somewhere, okay? Python script. We'll show you in the tomorrow session, we'll see it, okay? So with this, I'm going to wrap up. See, tomorrow we are going to start the machine learning model. Okay, that's very much, sorry, machine learning topic. That's very much important. Don't miss out. That's the fundamental building block to